Yes. Hello, everyone. Let's take. We are live. Yes. Okay. So, hello. Ladies and gentlemen, developers and tech enthusiasts from around the world, welcome to the Google Developers Cloud Community Istanbul live stream. I'm thrilled to have you join us today as we embark on a journey through the exciting world of cloud computing and innovation. I'm Omar, and I have the incredible privilege of being an organizer in this vibrant and dynamic community. Our community is a melting pot of creative minds passionate about leveraging the power of the cloud to build, deploy, and scale transformative solutions that shape the future of technology. Here at Google Developers Cloud Community Istanbul, we're all about fostering collaboration, learning, and growth. Whether you are a seasoned developer looking to dive deeper into cloud services or someone just starting to explore the potential of the cloud, you've found your home here. Throughout the year, we host the various engaging activities designed to enrich your cloud journey, from interactive workshops and hands-on tutorials led by industry experts to thought-provoking webinars and fireside chats that dive into the latest trends and advancements in cloud computing. We've got it all covered. But that's not all. Our community thrives on the energy and enthusiasm of its members. We encourage active participation, knowledge sharing, and networking. Connect with fellow developers, share your insights and collaboration on innovative projects that push the boundaries of technology. So, whether you're here to enhance your skills, stay updated with the latest developments, or simply connect with like-minded individuals, the Google Developer Cloud Community Istanbul is your gateway to an exciting cloud-powered world. Without further ado, let's dive into today's live stream where we explore the topic of Cloud Run and serverless solutions with Ervin Weber. Get ready to be inspired, educated, and empowered as we unlock the endless possibilities of the cloud together. Thank you for joining us, and let's make this journey unforgettable. So, to the stage, I will have Ervin. Hello,
Hello.
Ervin. I leave the stage to you. If you want, you can start by introducing yourself. The
Well,
stage is
I'm
yours.
Ervin. I'm founder of GTG Cloud Tallinn, and I'm coming basically from Estonia, which is same time zone as the host, but a bit to the north. And today I would like to talk about the Cloud Run because I really like this simple and elegant service, which gives you just, in my opinion, correct amount of control and convenience. So first of all, plan for today is very simple. We will just discuss what are the options to run something in Google Cloud. I will do some overview how I reached the Cloud Run as potentially best service for simple applications. I'll do a demo of Hello World, and we discuss things where the good Google Cloud Run shines and where it falls short. There is a common architecture diagram or table which allows everyone to score your deployment maturity levels. It's kind of framework and it has 5 levels. First level, we all have been there at some early parts of our life, is basically ad hoc deployments where the team has some code and they deploy it manually somewhere. It's all manual, there is no formal process, and not every team member does it exactly the same way. Second level is that when you have some kind of scripts, but process is still mostly manual, and still there is a lot of chance for failure. When you have an automated deployments level, then you have kind of fully automated process, but for example, you run it on your machine and still outcome can be different depending on who runs it. Then the next level is CI/CD. You have some pipeline, but it's not fully automated. And the ultimate level of deployments is continuous deployments when you just write code and it gets shipped. And I think that this maturity levels diagram is very useful when you are trying to pick yourself a service where you want to run your payloads, because the simpler it's to deploy, the simpler it will be to maintain. And if you have less mistake possibilities, the more stable your system eventually will be. And what are the common ways to deliver server applications nowadays? Well, if your compiler or programming language allows you, you can combine everything that your app has to offer into a single binary. For example, Golang allows that. In some cases, you can bundle Java in single class. And you ship this file to your customers, and it's up to them how they run it. Sometimes you have more complicated situation. For example, if language cannot be compiled or you have bunch of files, so you, for example, your common Node.js application, and best way to ship it was archive of some kind, zip file maybe. Next level is when you use some form of configuration that needs to accompany your application, and you are worried about some dependencies. You can do operating system package like MCI for Windows, Yum, or APK for Linux systems. And when your application gets deployed together with some configurations defaults, everything will be placed in correct folder, and you will also be sure that dependencies are also there. Of course, dependencies can go wrong, you have wrong versions, and people invented virtual machines to do the whole computer setup, bundle everything, and then you just give the virtual machine a single file to somebody to run. And it was nice, but most efficiently, of course, was to use open container images. Initially, they have been called Docker images, and difference was that you don't need to ship the whole operating system with them. And now you reach a situation when you have some application, you need to deploy it somewhere, and you figured out how to make a container, and you want to run it. So you go to artificial intelligence, be it ChatGPT or BART or something, and you ask like, how do I use my container? I want to run it. And obviously BART will give you some answers, you will follow them, and story is complete. However, we are professionals and we cannot simply follow whatever AI says to us. So next way to figure out how to run Docker container is to go to Cloud Native Computer Foundation and see what are orchestrators for payloads that are offered there. You will see all the different things like Kubernetes or Nomad or many other things. And difference is that if you have foundation behind your orchestrator, you can be sure that the project won't die unexpectedly, or it won't turn closed source, or just at random change the licensing to something that is not suiting you. So using CNCF projects gives you some kind of assurance and future proofing for your application. However, we are here in GDG Cloud. So what are the opportunities to use Google Cloud? And I will use illustrations by Priyanka, who is Google Developer Advocate, and most of pictures that you will see in the upcoming slides are borrowed from her GCP sketch notes, which are available in GitHub under Creative Commons licensing, or also you can buy them as book. The main 5 ways to run workloads or basically application on Google Cloud are Compute Engine, Kubernetes Engine, Cloud Run, App Engine, and Cloud Function. And I will briefly touch every one of them and say why it's good or not good for my goals. And of course, here is again the attribution for Priyanka's book. You can actually buy it as printed book as well, or you can find all the pretty images in GitHub, Google Cloud Blogs, and very plenty of different places around the world. I will also use the slide here about the cloud security, especially this part of shared fate when I'm discussing ways to run your workloads, because there is obvious trade-off between how much you manage and how much you control have. So sometimes you prefer to do everything yourself and have every bit exactly as you want it. Or for example, in some cases, you just want to write your code and let someone else to handle it completely. You will just say that this is my image and these are the people who need to access it. So App Engine. App Engine is actually the oldest Google Cloud service. And at some point, Google was not even sure if they do regular virtual machines like some competing clouds at time did, or they will go only with App Engine as fully managed service. This service launched to everyone in 2011, and it was taking your source code as input and did everything for you. However, in later revisions, flexible environment appeared where you can provide instead of source code the pre-built Docker image and use it. It's fully managed service, but it's also a problem because it is a closed source system and you basically get the huge vendor lock-in if you use App Engine. It gives some security adjustments to your container, but it can get pretty expensive when you use it because all the managed services, they have extra operational costs, which you have to cover by paying, not by your time. And I think huge problem of App Engine is limiting App Engine to single region per GCP project. Yes, you can have many GCP projects, but in every one, once you start your App Engine service, you are limited to single region. Next offering that is very popular is Cloud Functions. It corresponds to Lambda services in competing clouds, and it has support for limited number of languages like Java, Golang, Python, JavaScript. And it's HTTP triggered. You put your code, you get some form of URL back, and it can be cheaper for you because you only pay for seconds that you're actually using the service. So it scales to 0 when you're not using it, and you pay only things that you used. For input, this service takes always the source code of your application and builds it on Google Cloud build service for you. You cannot control directly how the image is built, and for me, it's limiting factor. And interesting that in new revision of Google Cloud Functions, actually the resulting container is running on Cloud Run version 2, and it was very interesting to see that one service is actually using second one in background. Compute Engine is Google Cloud version of regular virtual machines. I would say that it's very low level because you basically get virtualized hardware on which you run on virtual hard disk your operating system and configure everything. It has stateful disk, and every machine is in single availability zone. It's very fast to provision, and it's also the cheapest per second, especially if you consider spot virtual machines, which can be terminated at any time, or if you do committed use discounts and you say that you, for example, buying 10 cores for 3 years. There is almost no limitation on workloads. You can run any operating system that you have licensing for, and you get the whole management overhead. You will need to patch operating system, you will need to reboot machine to apply updates, etc. And at any point of time, your single virtual machine is not like platform. It's something that you usually combine with other machines to have resilient platform which has observability, service discovery. And for example, in case of spot machines, you always will build some system which will be fault tolerant to reboot of single machine, like you will do cluster of many machines or something like that. However, it also includes the standard way to provision single Docker container. If you configure machine through Cloud Console or via Terraform, you can say in instance metadata that you actually want to use the whole instance for single container, and that the container will be run for you on that hardware. So it's a working solution, but still we can go better if we don't want to manage the whole platform. Next offering is Kubernetes Engine. I think that Kubernetes today is most popular way to run your workloads, which are in form of containers. And Google is actually grandfather of Kubernetes because Borg was the system that Google used internally to run workloads. So Google experience in Kubernetes is basically 10 years more than anyone else on the planet. However, I still think that Kubernetes sometimes is pretty low level. It's like not the platform, but it's an important tool to build the platform. And especially if you are not playing exactly by the rules or dealing with node upgrades, upgrading cluster versions, sometimes it is also the management tasks that you have to deal with. There are platforms built on top of Kubernetes, Istio, Anthos, and many others, which help you to orchestrate containers at scale, automatically make encrypted connections between containers, maybe do some network firewalling and related things. But you still will be somewhat limited by capacity of your nodes. The Kubernetes does not scale automatically. However, many cloud vendors allow you to automatically add machines on demand, so the cluster can appear to be automatically growing. And in case of Google, you can also have an autopilot Kubernetes clusters where you will pay only for CPU and RAM provisioned to your containers, and Google will try to hide all the complexity of managing nodes away from you, but it will also come at a price. And that brings me to Cloud Run. Similar to Cloud Functions, it's fully managed way to run HTTP workloads in container. You provide your container, you get URL back. And difference with Cloud Functions is that you provide container, not the source code. All containers automatically get the HTTPS load balancer in front of them, and that balancer will, if needed, direct traffic to all the different containers that you run for this workload, so they can come and go seamlessly without causing any disruptions to the service. Your container just need to listen on some kind of port, which will be provided in the environment, and all the containers should obey the runtime contract, some rules that make experience much better if you follow them, and can cause you some small outages if you're not following them carefully. You can have Cloud Run job which runs all the time, or you can ask Cloud Run to throttle your service by detaching CPU when there is no requests, and in that case, you can actually pay per second only for used requests. Cloud Run automatically can scale to 0 if you are not using it for a while, and you don't need to provision anything in advance. With Kubernetes or Compute Engine, you have to create all the nodes beforehand, and you will be limited by their capacity. In Cloud Run, you just give a container and Google will solve everything else. As I mentioned, the App Engine was a service which was proprietary Google service, and it had a vendor lock-in because it was not open source. Cloud Run, however, is an implementation of Knative, which is now CNCF open source project, and technically you can run Cloud Run on your own machine in your own data center or anywhere outside of Google. And this is important because you have more control before you commit to the ecosystem, that you can run it at our provider or on premises if needed. So let's do a small demo. This link that I copied, it contains the demo Cloud Run container that can be used, but I will just switch my screen to the second tab, and I'm already logged into the Google Cloud Console, which I can use for demo. This is how the Cloud Run list looks in your average project. I just create the new service. I pick the sample container, which comes from the GitHub repository that I mentioned already. Let's give it a name. Let's say that we are using scale to zero opportunity. It will be a relatively small container. I will allow everybody to access this container for now. And I'll pick the smallest possible machine. Just do not pay too much. Our request will be very fast, and it should be enough to deploy the service. Oh yeah, absolutely. Cheap machine is not expected to handle much requests concurrently. That is also the difference between cloud functions, which always serve single request by single invocation and single instance. That in Cloud Run, you can say that your container with several CPUs can handle many hundreds of concurrent requests. So, new service is up and running. It has my container, and I can visit the link. It is working. It's very simple service to start using, and it's very easy to get running. Now let me continue with slides, please. What are the features that Cloud Run allows me to do with my container? First of all, I can have multiple versions deployed in the same URL and same service, but different containers with different content. And after that, I can do traffic splitting. For example, I can have canary release, which will be received by only 1% of traffic, or I can do A/B testing with different containers serving different people, so I can do marketing decisions based on that. I can also have sidecars in my containers if I need some proxy or wrappers or tunnels or whatever. I can assign the custom domains inside the Google Cloud Run service, but not in every region. And of course, Google takes care of security. I can say who are the Google Cloud identities, domains, or organizations that can access this particular container. There are pre-made integrations for Firebase Memory Store and Cloud SQL, which make the relevant services appear as simply sockets inside your container, which are already pre-authenticated and configured in all the firewalls correctly. So you just write the local socket and use Cloud SQL or Memory Store, for example. File system is virtual, so it means it is fast, but if you write large file to disk, it will consume the memory of your container, and sometimes if you are not careful, it can lead to out-of-memory errors, which cause the whole container to be killed. Cloud Run supports HTTP version 2, so if you want to, you can use gRPC protocol as well as your regular HTTPS. And this allows you to do, for example, WebSockets very easily. Cloud Run services run in Google Managed Network. They are not actually running in your VPC directly. In one case, it is good because it gives you isolation and security. From other side, you will need to do something to connect to your regular network. And containers are sandboxed, giving you extra security. If, for example, your container is written in a way that application runs as root, it will not be the root of operating system that runs this container. So if the container is somehow breached through vulnerability, the operating system underneath it won't be hurt too much. And Cloud Run, like any other tool, also has several shortcomings. First of all, Cloud Run is stateless. As I said, that any write to the hard disk is actually consuming RAM, so you cannot use them, and containers come and go dynamically. You cannot run any non-HTTP or gRPC protocols in containers, so you cannot put OpenVPN or, I don't know, run some form of database with custom protocol. Because container is not located in your virtual private network, you will need to use serverless VPC connector, which acts like proxy that authenticates your container to your network. Or on this Google Cloud Next few weeks ago, the direct access was announced with some limitations. And the contract for runtime of containers also has several limitations listed. For example, your instance must listen for requests within 4 minutes after being started. If your container fails to open TCP port on the port that was given to you by Cloud Run orchestrator, your container will be terminated and restarted. And for example, if your application is running migrations every time on startup of container and some of migrations are taking 10 minutes, then your application is not suitable for Cloud Run. If you have an request which comes to Cloud Run and there are no spare container, the new container will be spin up for this request. But if container is taking too long to start, the request will be discarded if container takes more than 10 seconds to start up. In some cases, it's fine, but in some cases, you need to be sure that your application is able to actually start listening on given port in 10 seconds. Autoscaler of Cloud Run always aims to have around 70% CPU utilization. This allows you to handle spikes of traffic, but it also means that your more complicated setup will usually have 30% of CPU idle and unused. Maximum HTTP request duration in Cloud Run is 1 hour. So for example, if you are doing WebSockets or any other form of long-run connections, you will need to be sure to reconnect every 59 minutes if you need smooth experience. Autoscaler will wait 15 minutes after your load is gone before the containers are scaled down. So if you had spike, you can expect that you will pay for 15 minutes. And when the container is shutting down, Google Cloud Run will give you 10 seconds between application is warned about upcoming shutdown through the SIG term and container is actually killed. In many cases, 10 seconds is more than enough and it forces you to write correct code. But in some cases, if you have long-running transaction, for example, you will need to restart the transaction in some other instance. And now I would like to take some questions if we maybe have some in audience.
Yes. So we don't have questions from chat yet, but I do have some questions. Maybe we can talk about the. Can you explain the billing and pricing model for the Cloud Run, and how does it compare to other cloud services? If we are not going to talk about it in the future.
No, I did not have special pricing section. Pricing model is very simple. The RAM and CPU is billable, so is traffic. In case if your container is configured to detach CPU when you have no requests, you pay only for seconds when you are handling the traffic. And in this case, you pay every second a bit more than if your container is running all the time. The traffic itself is free inside the data center as usual, but you will pay for outgoing traffic across regions.
Nice, great. Oh, we have a question from Emir. Emir says, "Thank you for the great presentation," and asks, "How do you access Cloud SQL from Node service in Docker container with the Cloud Run Cloud SQL integration?" He says, and he further expresses that he couldn't find enough documentation about the topic.
For example, in case of PostgreSQL, you will have an socket, which is basically a special kind of file in operating system. And you will point your database application to connect instead of hostname of database to that file. And Cloud Run will do REST automatically if you configure integration correctly, that is. So
Nice.
instead of providing IP, you just say that var run PostgreSQL is the file where the database is located, and application will just work if you have correct PostgreSQL driver and integration configured. And I guess it's the same with MySQL or Oracle databases.
Nice, great. Another question that came up to my mind. What security features and best practices should developers keep in mind when deploying applications on Cloud Run?
You
Maybe,
definitely need to read the contract that I mentioned. It's called Cloud Run Runtime Contract. It's very short document and it gives you the pretty good overview. And some of other best practices I have on the basically next slide, which lists things that you need to think of if you're doing the enterprise grade secured hardened setup.
nice, great. So I believe that's it for now. We can continue with the slides if it's
Yes.
possible.
And here we go. So what are the things that I think that are important to do if you're doing like not hello world, but some decent setup? First of all, you will need to put the Google Cloud Load Balancer in front of your service. This will unlock you with several Google Cloud Load Balancer standard features that you cannot by default control in Cloud Run. First of all, you will get the custom IP, which will be the static IP, for example, if you configure it so, and you will be able to define Cloud Armor policies, which can, for example, help you with DDoS prevention, or you can ban some, I don't know, bad IP address, bad requests coming from particular IPs. Like, I don't know, maybe you need to ban some countries if you don't want to implement GDPR, or if you are being victim of some malware coming from particular IP, the Cloud Armor can help you with that. Load Balancer allows you to use CDN, which will basically cache the files from your Cloud Run container at point of presence closer to your customers and will be very helpful. or you can use identity-aware proxy. As I mentioned, the Google Cloud Run itself, it can allow you to have allow list-based access to your instances. So the requests will reach your container only if they have proper authentication header. The identity-aware proxy is basically login with Google screen that you can put in front of your application, so you don't need to deal with authentication inside the app. Instead, you will have login screen and authentication validated by Google itself, and only people with correct Gmail, Google Workspace, or custom domain emails known to your organization will be allowed to reach your container. I believe that Cloud Run services should not be public, and they should be configured either to be accessible only from your VPC or from VPC and load balancer if you really need to have traffic outside of Google Cloud reaching your container. And the same thing is about the outgoing traffic. You should really direct all the outgoing traffic to serverless VPC connector. And inside your VPC, you can configure CloudNut and to do VPC flow logs. That way, you will be able to log all outgoing traffic from your container and be really aware if there is some malicious activity going from your application to some unknown IP that you didn't expect. And three things that greatly help with supply chain security are binary authorization, which requires your containers to be digitally signed with known authority before they are allowed to run in your services. Salsa is a framework which includes guidelines and rules for every step of your code to production service journey, ensuring that you will be less vulnerable to some man in the middle or malicious actor in the middle attacks on the whole journey from your developer workstation to the code that runs in production. And EASBOM is a very useful technique where your container will be including not only the binary that is your application, for example, which is minified and compiled, but also will have the bill of materials or list of all the packages that have been used to produce that binary. And in that scenario, for example, you can easily say that your container is vulnerable or not vulnerable to some freshly discovered vulnerability. It's very useful because if you don't have this information, you cannot say which are the containers that, for example, are affected by log4j problem. But if you have this metadata in your containers, you're good to go. And if I would need to pick like 3 best features that I'm taking from this list, it would be binary authorization, identity-aware proxy, and ability to have VPC flow logs if traffic is directed from my custom network, which are the 3 steps that I think are most important to have very, very secure setup. But that's all with my slides. I would like to talk or take questions from audience now. Feel free to join me in LinkedIn if you have some questions after the show as well.
Yes. Thank you so much for the presentation. I believe that it was very much valuable. Emir comes with another question. He has found Cloud Run to be more costly than Cloud Functions. Maybe after going over the 2 mil Cloud Functions fee tier requests, the pricing of Cloud Run becomes more attractive. Maybe a question mark.
Well, thing is that the Cloud Functions version 2 environment actually runs on Google Cloud Run, and you can even see relevant containers listed under Cloud Run services in your Google Cloud project. So I would say that pricing is more or less same. However, for example, in Cloud Function, you always have one billable instance per incoming request. On Cloud Run, you can multiplex requests so that if there are, say, 5 incoming requests, you need only 1 or 2 containers to handle them all, and you will pay only for 2 billable CPU seconds at that time.
I see. Well, hope that answers your question, Emir. Another personal question of mine. Uh, what tools and integrations are available for monitoring and debugging applications running on Cloud Run? Can we talk a little bit about that?
First of all, you will get your traffic monitoring in the same way as you would get for regular Google Cloud Load Balancer. You will also have metrics for CPU, number of CPUs running, and uh, memory consumed by your applications. The cold start times will be also measured, and actually probably can just share the metrics screen of the application. A second.
Yes, of course.
You probably now see it.
Yes.
If I open the 18 Cloud Run service, I will be presented with metrics page by default. These are throwaway hello world container that I deployed yesterday, so there is not much. However, you can see that requests grouped by status, what have been latencies of such requests, how many containers I had, how much I will need to pay for that, because sometimes I can have 2 containers with half CPU each, and that will be only 1 CPU second per second. I have utilization metrics that will help me to estimate if I need bigger or smaller containers in the future. Traffic estimations, because traffic is billable, and things like concurrent requests and startup latency. This is what you get out of box. Additionally, you can get traces emitted by load balancer that is in front of your application. And very good practice is if you do serious application, you should actually use OpenTelemetry inside your application code. I think, well, it's not industry standard just yet, but we are getting there.
Yeah,
And Google Cloud Services themselves, they also obey and emit OpenTelemetry traces
I
if
see.
they see them.
So, generally, when we're talking about monitoring and these topics, what comes to my mind is performance. So, as a developer, or as a cloud developer, do you have any best practices or tips you can share for optimizing performance and cost efficiency on Cloud Run?
This is mostly will be depending to your programming language that you are using. Basically, don't put garbage code inside your container, make container small, and the smaller container will spin up faster, scale down faster, and you will pay less.
I see. So the less and compact it is, the more fast and the more optimized it's run.
Yes,
So
because you pay per second for CPU and for memory.
I see. Uh, can you describe any future developments or trends you anticipate in serverless computing and cloud run specifically? Maybe in this age we have large language models and generative AI booming in this year. How does this affect cloud run or other sectors? How does it affect cloud run as you see as a cloud developer?
Well, I think that models actually should be somewhat detached from container, like the Google Cloud own model garden. You can train your model and access it later from different containers, for example. Also, I recently saw the blog post in Google Cloud community where someone took pretty standard LLM image and made it from 4 gigabytes to to around 1 GB, and
Nice.
it was basically by throwing away that things that are included in the sample image for convenience, but actually are not useful if you're running on Google Cloud. Like, for example, in Python, you very often have 3 sets of drivers for different video cards, but in reality, your container on Google Cloud Run or somewhere will have only one particular GPU attached to it. So you
I
don't
see.
need other drivers. You can pay less for container.
Yeah, yeah, of course. Emir has another question. For scalable microservice architecture, what is the best practice cloud functions or cloud run?
I think it's mostly a question of your preference, especially if we know that Cloud Function Generation 2 runs on Cloud Run Generation 2 in background. For me, there is very big blocker for using Cloud Functions is the artifacts that they use. To deploy Cloud Function, I need a zip file of my source code. And when you have half of your company software developed and archived in Docker registry, and having some zip file registry next to it feels somehow non-standard. And in many cases, Google build packs that used to build your container are very, very good. But for example, I have more than once stumbled onto a situation where Cloud Functions and build packs have disagreement with me about how to build the container, and I cannot influence it in any way. A good example may be the JavaScript and Yarn, for example. Yarn guidelines say that Yarn should not be used in production. You always run your software directly as node and your package, for example. However, build packs will insist that you need to use Yarn start, for example.
I see. Thank you. Finally, let's close up with this question. Do you have, maybe as a seasoned developer, are there any case studies or success stories you can share about companies that have achieved significant benefits using Google Cloud Run?
Well, Cloud Run is a tool. Usually you achieve success because your product is helping somebody, not because it runs in Google Cloud Run or not runs in Google Cloud Run. For me, Cloud Run was unlocking the power to move fast, for example. But I know that at some point of scale of company, we will switch to use something like Compute Engine or maybe Kubernetes because we will need to pay less per second.
I see. Thank you for your insight. Another thing that came up to mind. Well, I aspire to be an MLOps developer, so continuous integration and continuous deployment is very important for us. How does Google Cloud Run handles continuous integration and continuous deployment pipelines, CI/CD for short?
I think there was some built-in integration which allows you to automatically deploy to Cloud Run your GitHub or Google Cloud Source repository, master or main branch, like on every change, basically. That is actually also a good point about the Google Cloud Functions versus Cloud Run. In case of Cloud Run, you can have single container which will go to development, pre-life, life environment. However, with Cloud Functions, you always get new container built from your source code. And depending on, for example, how tightly your package is locked, you actually can get different containers in different environments on Cloud Functions.
I see. Thank you. Well, I believe this is it for today. I don't have any further questions, and I believe the viewers also don't have any further questions. But if you have any further questions that came up to mind, you can connect with me or connect with Ervin Weber, as he stated on the in his presentation. You can connect with him on LinkedIn, I believe so. So
Yes.
thank you all for coming. Hope to see you again in our next event. Thank you so much. So
Have a nice
see
evening.
you
Bye.
soon. Have a nice evening.